All right, let's go over the next series of problems, which will be problem 5. 5 is a two-part problem, and what we'll be looking at specifically is solving certain inequalities with the sign chart method. So let's look at part A. So we're going to have, this is part A, and our equation's x to the third minus 3x squared minus 4x plus 12 is less than 0. This less than plays a really important part here. We are specifically looking for values that are less than 0, which are going to be negative terms on our number line when we get to that point. And I'll explain it further when we get there. This will also affect our interval notation, which we have to put it in our solution in interval notation, which I will also explain. So let's start off first by simplifying this equation. So if we're looking at it, we should have we should be able to condense this equation quite well. We're going to do this by factoring by grouping. So we take this term and this term and then factor it accordingly. So here right away we can see that we could take out an x squared and we should be left with x minus 3. And then in this term we'll take out 4, negative 4, and we should get x minus 3. So our terms match up perfectly fine, and that works out for us. So we should end up with x minus 3 times x squared minus 4. And you should be carrying this less than 0 with us as well throughout our whole problem. So again, our first step was factor by grouping. We take these two terms, we factor it, and then we get left with this. And we can go actually a further step with this term. This is going to be a difference of squares. So we have to split this up. We know that negative 4 or 4 squared is 2. And we know x squared is just x. So we'll get x plus 2 and x minus 2 as additional parts of our problem. So our full problem then should also be, we'll carry this down here. And we should have x minus 3 times x plus 2 and x minus 2. So now looking at this, we should solve for each individual problem and see these numbers will directly correlate to our number line. So first off, we have x minus 3 is equal to 0, which we will add 3, and x will equal 3. We'll do the same for these two, but respected two values. So we'll have x is equal to negative 2, and x is equal to positive 2. Again, these are going to be our values for our number line, and we'll put our number line over here. Make sure you give yourself enough room. So our first value, going smallest to highest, we'll have negative 2, 2, and 3. And we need to figure out what parts of each section of this number line will work according to what we're looking for. Again, in this situation, we're looking for negative values because we're working with less than 0. And we don't work with include here, so our points are going to be not including. So let's start with negative 2. We always want to pluck a number right under it to make it a little easier. So in this situation, let's pluck, and we're going to the left here, so we're increasing numbers to the left. Where if we were going all positive values, we'd be decreasing our value, which you'll see later on in the same problem. So we'll take negative 3 in this situation and plug it into our entire equation. So we'll take negative 3 minus 3 times negative 3 plus 2, negative 3 minus 2. And for these types of problems, you don't have to actually solve them. You just need to make sure you know what the end value is going to be. So here, that's a negative minus a negative, which would be negative. This value we know is going to still be negative, and we have a negative. So right off the bat, we're able to tell if what our first term is going to be. So this is going to be plus once we multiply these together, and then a negative times a positive is a negative. So our first term, or this first area, will be negative. So we'll put a little check mark as well to note that's what we're looking for. Now let's look at our second part. And we could change color here to make it a little easier to decipher against. We'll actually pick 0, because that's in between both these values, and it'll be super simple. So 0 minus negative 3, 0 plus 2, and then 0 minus 2. We'll get negative, positive, negative. This will give us a negative and a negative, which will in return give us a positive. And we're not looking for that. We could also say f of 0 if we wanted to. So our work's going to get a little bit sloppy here. That's going to be okay. In fact, I might just move it to make it a little easier to see. We're going to condense this a little bit. And we'll put our work right here. So now looking at this side, we'll do 2.5, because that's in between both terms. So we do 2.5 minus 3, 2.5 plus 2, and then 2.5 minus 2. So we get a positive, 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 or excuse me, negative. And we should end up with a negative after these two multiply times a positive, which should also give us another negative, making this area work out for us. Now looking at our last area, we will go over here with it. We'll change our color again. And we'll have 3, so we'll just do 4. So we have 4 minus 3, which will be positive, 4 plus 2, which will be positive, and 4 minus 2, which will be negative. So which will be positive. So this will be positive, and we're not looking for that. So we'll switch to blue just to represent our parts. So I like to say this out loud to help me kind of visualize the domain or interval notation of this problem. So this is negative, so we'll include everything from negative infinity to negative 2, not including, given the certain restrictions of the problem. And the positive area we're not including, so we'll exclude this, and we are including 2 to 3. Or not including 3 to infinity. So then in return, our answer will be negative infinity, comma, 2, negative 2, not including, union, and we skip this interval right here, 2, comma, 3. And that will be our answer for part A. Amazing. Let's move on to part B. Part B is going to ask us to do something really similar, just a little bit different as far as what our problem looks like. So part B will give us 2x plus 8 all over x plus 3. And this is another great area to look for restrictions when we're talking about rational functions. So just to make sure you understand, this is a polynomial inequality, this is a rational inequality, and this is going to be, and the only difference here is that if we have restrictions, we can see a restriction if we're talking about a polynomial. If we have a root of something, that the restriction for that is that it has to be equal to or greater to 0 if it's a even root. But in this situation, and we can also see that with rational functions as well, in this situation we just have a fraction, so the bottom term will be our restriction. So no matter what x cannot equal to 0. So this will always not include. So we have x plus 3 cannot equal 0, and that's just going to be x is equal, or cannot equal, negative 3. So we still have to include that value on our number line. Now we're going to look at our top value. So this will be our bottom value. But let's finish the problem. So this can be greater to or equal to 0. Remember, this is incredibly important. So we're looking for things greater than 0, so the positive terms, but we can also include 0. So majority of our points excluding this negative 3 because it's a restriction will be positive and will include. So we are going to have 2x plus 8 is equal to 0, and we're going to solve accordingly. So minus 8, so we should have 2x is equal to negative 8 divided by 2, x is equal to negative 4. So in this point in time, we'll only have two numbers on our number line. Let's draw that over here. We'll have negative 3, which we already talked about, we are not including, and actually we'll have negative 4 because that's a smaller number, and this is including. Negative 3 will be right here. That's not including. And we'll find our values for these. And when we're plugging these values in, we'll plug it into the entire equation. So no matter what we plug it into, our rational function, wherever x is. So let's start with this area right here. We'll do negative 5. So negative 5, we'll draw our arrow to notate that we're doing this area. 2 times negative 5 plus 8 all over negative 5 plus 3. So right off the bat, we'll have negative 10, so we have a negative on top. And this value here will have a positive, we'll have a negative again. So we have a negative divided by negative, which will give us a positive value. Let's do our second area. We'll change color again. Let's do negative 3.5. So we'll do 2 times negative 3.5 all over negative 3.5 plus 8. Don't forget that part. Plus 3. So again, this is going to be 7. So we'll actually have a positive over a negative, which will give us a negative value. Now looking at our final area, we'll use 0 to make it easier. So 2 times 0 plus 8 over 0 plus 3. Right off the bat, we could tell it's going to be positive. 2 times 0 is 0, plus 8 is a positive 8. 0 plus 3 is a positive 3. Positive over positive will give us a positive value. So now we'll talk this out. We want all things bigger than 0, and we can include 0 except for this restriction, which is negative 3, so that's why we don't include it. But we're talking about everything from negative infinity to negative 4. This is a negative section, so we don't include it. And we start at negative 3, not including it, all the way to infinity. So our answer in interval notation will be negative infinity to negative 4, including negative 4, so we use a bracket. Union, negative 3, not included, so we use a parentheses, and it would be to positive infinity. And that's how you solve for a rational inequality as well as a polynomial inequality. And thank you so much.